This video is on exercise 6 from lesson 18 in the grade 8 module 4 book, so it's on page 105. So in this one it says a group of friends are on a road trip. After 120 miles they stop to eat lunch. They continue their trip and drive at a constant rate of 50 miles per hour, just 50 miles per hour. Part A says let y represent the total distance traveled and let x represent the number of hours driven after lunch. Write an equation to represent the total number of miles driven that day. So in this one, something to point out. We have y represents the total distance traveled, so that's kind of normal. X might be a little confusing if you read it too quick. X doesn't just represent the number of hours driven. It's specifically the hours driven after lunch. Okay, so down here, if we look ahead to our x-axis, this actually should say hours driven after lunch. Gotta change that up a little bit. Okay. So when we talk about y represents the total distance driven. That is going to be the whole goal of our equation. So we're going to start out with y equals, and remember that, so that's kind of saying that the point of our equation is to find the total distance traveled. So the total distance traveled, y, is found by, so is, which is what the equal sign means, and over here we have to write how those miles kind of add up, how we get the total miles after x hours. Now, I'm going to put an x in there. X does represent the number of hours driven after lunch. The speed. So remember, when we have linear equations like this, where we have a constant rate of change, our rate of change is the m. In this case, our rate of change is 50 miles per hour. So the rate of change goes with the x. It multiplies x. Then, after it, remember when we talked about y equals mx plus b from the last exercise, the b was the beginning amount. Now in this case, remember, x stands for the number of hours driven after lunch. So the total distance, the beginning amount, is what they begin by doing right after lunch. So right here, hours driven after lunch, well, how many miles have they driven starting immediately after lunch? They've already driven 120 miles. So 120 is our beginning amount. Because again, x stands, we're starting this graph after lunch. We're starting after lunch, they've already driven 120 miles. So we'll just put our plus 120 there. All right, so next part, identify the slope and the y-intercept point. What do these numbers represent? We kind of just talked about that. So in this case, slope equals 50. 50 is the rate of driving. In other words, 50 is the speed. It's 50 miles per hour because x stands for hours. So 50 is the rate of driving. Y-intercept point. Well, the y-intercept point is 120. So we go y-intercept equals 120. 120 is the number of miles already driven before x starts counting. Because remember, x is the number of hours driven after lunch. So we're not going to start counting for x until they're done with lunch, until they start driving after lunch. Okay, so now they want us to graph the equation on the coordinate plane. Well, that's easy enough. Remember, we're going to use B to find our first point. So first point is going to be 0, 120, because our B is 120. B is always the number that's constant, that's not with x. So first point, let's see, goes right here, right there on our graph. 0, 120. Our next point is found by using the slope. So slope is going to equal 50 over 1. Again, slope is 50. So our rise over run is 50 over 1. So let's see, they are counting by 20s on the graph. We can see how it goes 0 to 20 to 40 to 60. So I actually want to think of it like this. Slope is also equal to 100 over 2. The reason I chose 100 is because it's easy for me to see how to go up 100. Let's see, I go up from 120 up to 220. That's a 100. And then I go over 2 hours. Then I'll just take my ruler and I will connect my points for my line. So there we go, got my ruler, well, got my line, I should say. Gonna label it up with my equation. There we go, make sure we get full credit on that. Okay, now part D, last thing we got to answer. Could any other line represent this situation? For example, could a line through the point 0, 120 with a slope of 75 represent the total distance the friends drive? Explain. So let's kind of look at what would happen there. They give us an x value of 0 and a y value of 120. So in our equation, we have y equals 50x plus 120. Hold up though. They actually are changing the slope on us. So they're changing the slope to 75, and they want to know, could that represent this situation? So we will cross that out. I can erase it. We'll put 75. Then based on the information given, or actually I should say based on the line we drew, so this line we drew represents the situation, does this equation match that? Well, I should be able to plug in this coordinate point right here, 2, 220, x value, y value, and that should work in this equation. So let's see if it does. Let's see. Y value of 220, 75, x would be 2 plus 120. So if we solve all that through, what do we get? Well, let's see, 75 times 2 gives us 150. 150 plus 20, or plus 120, gives us 270. Well, wait, that's not true. That equation does not match what we have. So when we have 75, that messes everything up. So we would say the equation and its line from the situation result in 220 miles driven 2 hours after lunch. Changing the slope to 75 does not match this.